Good morning, wonderful students. This is Mr. Morales, and this is pretty much, I think, will be our last topic of new stuff before your final exam, which would be next week. So this week's lesson is about condensing and expanding logarithms, basically taking logarithmic expressions and either making them longer or making them smaller based on the rules that we learned last week. And to address again the next week's assignment, next week I'm going to come up with a quiz, probably over just basic properties of logarithms, nothing else. And it'll be a short quiz, 10 questions or less, I'm guessing. And it'll be posted and it's going to count as your final 9 weeks exam test grade. There is still school after that. They're kind of hazy about how we're counting it. So what I decided to do is I'm going to keep posting lessons like always. And then what I'm going to do is I'm going to use those additional lessons as extra credit for the third 9 weeks for those of you who successfully complete them. All right, so be looking out for that next week, but let's go ahead and talk about today's lesson. So the assignment is titled Putting It All Together. And if you notice, it starts with number 19. And that's because this is really a continuation of last week's lesson. I am aware that I sound like I'm talking in a cave. And if you hear some background noises, it's probably my dogs rustling because now that I'm home all day for these last 2 months, they live to play and wrestle around me every chance they get. So minding the background noise, let's go ahead and get back on task with today's lesson. So you have problems 19 through 32. Obviously, like typical fashion, most of these seem to progress in difficulty as you go on from one section to the end of it. I will be truncating or cutting off some problems from the homework assignments, so listen out for that. And I am taking out some of the most complicated ones in my mind. So that's good news. So your work should be pretty manageable for this week. I have included, once again, in this week's post, the properties of logarithms graphic organizer in case you haven't printed it out or don't have it saved to reference for this assignment. And I would imagine this is going to be beneficial for next week's quiz as well. And basically, we have all the rules here. And what I really want you to kind of look at is what's happening in this middle section. And here's the gist of what today's lesson is. We're really going to take a small, simplified logarithmic expression and expand it to make it bigger using the rules pertaining to the way it's set up. Or we're going to go in reverse order. We're going to take an expanded expression and simplify it or condense it to make it smaller. That's all we're doing today. So this chart will be very beneficial in helping you derive the answers for today's assignment. And as always, there's numerical examples here, as you can see how the setup works going in both directions. And it even says condense and expand. So depending on what they're asking you for the assignment, you should know what your answer should look like. We will also be using Desmos again for the beginning part to get some numeric answers. So make sure you have Desmos up and running, ready to go, or any scientific calculator that can find the calculations of various logs for you as needed. All right. So with no further hesitation, let's go ahead and get into today's assignment. So I have the nicely done notes already, and I'll just explain them to you one bit at a time. So our instructions at the beginning say rewrite as a single logarithm and simplify if possible. So we're going to be taking logarithms and making them from a expanded version, like we have here, to a more simplified version. So a couple of things. When you are condensing or simplifying, and it even says on the side, condensing, basically all your answers should start off with the word log and whatever base you're using. So here we already have log. We took our property, and from our list over here, we have the power rule. When you have a number in front of a logarithm, the word log, that letter or that number can be taken as an exponent. So that number travels right here as an exponent. Sorry, my pen's not working. There we go. And it ends up looking like this, which is what they did here in step 1. So they wrote this as a log of x squared and then minus sign. One little trick for me is whenever I see subtraction, I know I'm going to be dealing with a fraction, and vice versa. If I have a fraction somewhere in here, I'm going to be dealing with subtraction when I expand it. So the subtraction sign becomes my fraction bar, and that is based on the rules we have here, the quotient rule. When you have subtraction of two logarithms, you can condense them by making them a division problem. The first logarithm divided by the second logarithm. The first divided by the second. So what we're going to go ahead and do now is apply that rule over here. So we had 2 becomes the exponent of 6, which effectively gives us 6 squared over 9. Simplify 6 squared. 6 squared means 6 times 6, or 36, over 9. Simplify 36 over 9, and we get 4. Notice the word log just came along for the ride, so there was no actual calculation per se there. For number 20, same exact thing. The 4 in front of the word log travels as the exponent for the a, so we get a to the 4th power. And then we have this 2, which travels to the exponent for the b, and we get b to the 2nd power. Both of these terms have a log base 4. Now, since I have addition, I go back to my chart here, and when I have addition, I can write that as the product of 2 logarithms, m times n. And that's what they did here. They kept the log base 4. And if you wanted to make it look like your graphic organizer, think of it as a to the 4th power times b squared. We don't know what a or b is, so we can't do any simplifying, and that's pretty much where it ends. Going on now to number 21. 21 and 22. So we have 7 log base 4 of u. We know that 7 will travel to be the exponent for u. And then we have minus, and then we have 3 log base 4 of v squared. Now v squared already had an exponent of 2. So this 3 will be multiplied times 2 to give us a total of v to the 6th power. Now we have the same base, log 4. We have subtraction, which means we're going to have a division problem. The first term, u to the 7, over the second term, v to the 6. We don't know what u or v is, so we can't simplify any further. And number 22, in these first 4 examples, same exact thing. But look, and now I have multi-step. I have addition first, and then I have subtraction. Everything's log base 2. So my final condensed answer will begin with a log base 2. Now I take my rules and go from left to right. Whenever I have addition, that means I can multiply my first term times my second term. So basically I have 15 times 4. The subtraction sign means I'm going to have a division, or the actual fraction bar word is called a viculum. You're going to have a fraction bar, you're going to have a viculum. You're dividing by your last term in this case, which is 6. 15 times 4 is 60. And that's kind of what you left off right here. 60 divided by 6 gives us 10 with the log base 2. All right, so all we're doing is just rewriting using the properties. We haven't done any particular solving yet. Now for 23, it's the same kind of thing. I have 2 properties. Actually, I have 1, 2, and it's like I'm going to have 3 properties involved. So let's see what happens over here. So I have 1, 2 properties. First of all, let's go ahead and take the first 2 pieces, this and this. So what I have here is log base 3 of 4 plus log base 3 of y. The product rule says I can just multiply those things, 4 times y. So that's what they did right here. They did 4 times y. Then they used the power rule and took this 1/2 and they made that the exponent of 49. 49 to the 1/2 power is the same thing as the square root of 49. The square root of 49 is 7. So we have a 7 out here. I thought that this was maybe a division symbol, but I guess it's just another plus that didn't come out right. All right, so we're cool there. So since we have addition, that means we can still multiply this last term times the first 2. 4 times y, which was the first 2 that we had, times 7. Well, 4 times 7 is 28, and then we just have times the y. It goes along for the ride. So that's how that one condensed. Let's be careful with these signs because I can see why it might get complicated. This again, we can say is addition sign. So we have 1/3 in parentheses times log base 5 of 8 plus log base 5 of 27. So just like PEMDAS, let's start with what's in the parentheses. We have log base 5 of 8 plus 27. Well, the product rule says we can write that as 8 times 27. Since we have 1/3 in the front, we can use the power rule, and that becomes the exponent not only for the 8, but also for the 27. So both of those are raised to the 1/3 power. When you raise things to fraction powers, you're really kind of doing square rooting. So in this case, instead of doing the square root, we're doing the cube root. So the cube root, let me finish this last part. Subtraction means we have division of this last term, 3. Now let me clear up the numerator. 8 to the 1/3, you can just use your calculator, 8 to the 1/3 power, or think of it as the cube root of 8. One number times itself a third time gives you 8. That would be 2. Same thing for 27. The cube root of 27 is 3. On the top, I have 2 times 3, which is effectively 6. 6 divided by 3 is 2. Or you could just take in what they had there, cancel out those 3, and you still get the 2. So basic algebra 1 going on there. The only thing that's different is the word log is traveling around. Really, that's pretty the only difference. And now for our last two examples for condensing. So we have subtraction in between these two pieces. So I know I'm going to have a fraction bar. Everything is log base 2, so I just bring that down for a ride. I can even kind of take it out now if I want to. Now, this 3 travels to become the exponent for 4, so I have 4 to the third power. Then I have over 32. 4 to the third power is 64. 64 divided by 32 is 2. So that one cleaned up nice. That one didn't get complicated like these typically do towards the end. Now, next piece. 2 log 6 becomes 6 squared. Minus means I'm going to have a fraction problem. 1/4 becomes the exponent of 16. So what is the 4th root of 16? That is going to be 16 to the 1/4 power is going to be 3. Actually, it's going to be down here. 16th to 1/4. I see what they did. I'm not going to get into the 16th to 1/4. I'll just say that this becomes the exponent. So between these two pieces right here, I'm going to forget about this last piece for a second. They said, okay, we have log that goes along for the ride. The 2 is the exponent for 6, so 6 squared. The 1/4 is the exponent for 16, 16 to the 1/4. Then we have plus log base 3, so they have that right there. Now they went ahead and it cleared all this up on the top and the bottom. So 6 squared is 36. 16th to the 1/4, or the 4th root of 16, is 2. Then we have plus log base 3. The product rule says when you have two terms with the same log, you can go ahead and just multiply them. So 36 halves times 3 is 54. That's how that one got its final answer. So a lot of remembering the rules from those properties of logs. Now, those are the fast, easy ones. Those are the condensing. Now we're going to expand. So they want us to, in our next set, expand each logarithm, do the opposite. So we're going to make each problem from a short one to a longer one. So in this case, we have log base 6 of x, y, z to the 4th. Well, that means we can break each piece, the x, the y, and the z to the 4th power, and throw the word log base 6 in front of it. So we get log base 6 of x. Since it's all multiplication, the product rule says we can add each term one at a time. So log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. Bam. Now, all they did was they took the last piece because we don't want to leave an exponent hanging here. So what we're going to do is bring this 4, and using the power rule, it goes in front of the word log right here. So the first two terms stayed exactly the same. Log base 6 of x, log base 6 of y, plus, and then now we have 4 log base 6 of z. That's the only difference. They just made it longer. So every answer for these last sets, when you're expanding, should be longer than the original. Now we have log base 4 of a to the 9th divided by b. Remember from our rules, the quotient rule, if we have a fraction involved, that means we're going to have subtraction. We can give each piece its own log base 4. So log base 4, log base 4. The first term, a to the 9th, goes with the first log. The denominator, b, goes with the second log. And then all we did now is do the power rule, bring that 9 in front of the word log. And then we have 9 log base 4 of a minus log base 4 of b, period. Next two examples. Log base 7 of q to the 4th r squared, that's squared. So first thing we're going to do is the power rule. We want to clear up the outside of this parentheses before we can deal with the parentheses stuff. So this 2 will come in front. So we have a 2 in front of parentheses log base 7 of q4, log base 7 of r squared. Since those are being multiplied in parentheses, they can be added based on the product rule. Now we go ahead and we're going to use the power rule and bring this 4 in front of log and this 2 in front of the word log, which is what we get down here in the next line. And then since we had a 2 in front of those things in parentheses, we're going to go ahead and we're going to multiply those out. So that gives us 2 times 4 log base 7 of q. 2 times 4 is 8, so 8 log base 7 of q. Then we have 2 times 2, which is 4 log base 7 of r. That's why it's all squished up there. So I want to explain that pretty detailed. Now, number 30. I know since I have a division problem, I'm going to have subtraction. Everything's going to have log base 2. So log base 2, log base 2. Now, here, power rule again. The 2 will come in front of the stuff in parentheses. So that's this 2 right here. I already had my log base 2 set up. The numerator is my first term. My z to the 5, my denominator, is my second term. Now I multiply both of those terms by 2. So 2 times log base 2 of y is 2 log base 2 of y. 2 times, oh, I forgot to do the power rule right here. So this 5 comes down in front. So now it's 5 log base 2 of z. 2 times that 5 I just brought down is 10. 10 log base 2 of z expanded. And finally, our last 2 examples, which are cut off here at the bottom. There we go. So now we have the square root ones. These ones are in your notes, but I did take them out from the assignment. These are the last 2, numbers 9 and 10, I think, or whatever, 19, 20, whatever it was from your assignment. The last 2 are cut out. So if you download the paper, just don't bother with the last 2. But, you know, if you really want to give them a shot, I will still include the answers on Friday. So here, what you have to do is remember how to rewrite square roots as exponents. So we have log of the square root of 7x cubed. You can rewrite 7x cubed, the square root of 7x cubed, like this, to the 1/2 power, because square root means to the 1/2 power. And then using the power rule, this would go in front of the word log, which is what they have right here, right there. And they said, okay, it's log of 7 plus the log of x cubed, because 7 times x cubed, just use the product rule to split them apart. And they said, okay, now we use the product rule on this last piece, because we had an x cubed. That 3 comes in front of the word log. So we have half of log 7, half log 7, times half of 3, or 3/2, log x. So it's really not that complicated, but you have to remember a little bit back. Log base 3 now of the 4th root. The 4th root means you can rewrite m5 times n2 to the 1/4 power. So whatever root you have, you just write it to the 1 over whatever. So 1/4, parentheses, log base 3 of m5, log base 3 of n2. Power rule means this 5 goes in front of the word log here, this 2 goes in front of the word log here, and you end up with this line. Multiply these coefficients times 1/4. 5 times 1/4 is 5/4. You don't have to give me the decimal answer for this. 2 times 1/4 is 2 over 4, or 1/2. So they kept everything as a fraction here. Now, let's get into this week's lesson. This is the basic notes. Feel free to go back, and I'm very sure most of you guys have found other ways to assist you with these assignments, considering I get almost no questions. So kudos to you for that. Your assignment looks like this. So it begins with number 9, and so does the Google form, and it goes through number 18. The Google form goes from 9 through 16. 17 and 18 are the ones I took out. So don't worry about inputting those. These are the ones I'm really grading, these 8. However, the first 4, they're going to actually ask you, I'm going to ask you to give me the decimal answer. So for example, for number 9, we have subtraction. So since we're condensing, we're going to make it a smaller problem. Subtraction means I'm going to have a fraction. I have the log of base 9. So I just write it as log base 9. And then the first term is 35. The bottom term is 7. Can 35 over 7 be simplified? It sure can. We would get log base 9 of 5. Oops. Well, what is the log base 9 of 5? I want you to give me the decimal answer. So it's going to be point something, something, something. It probably goes on more than that, but give me the first 4 decimal numbers for these answers. For 9, 10, 11, and 12 only. If you have a number in front of the decimal, give me that number also. If it's just 0 point blah, 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 then give me blah, 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 then give me those next 4 numbers. So actually, not only condense them, find the numeric value. So log base 9 of 5. If you're still paying attention to my video, then what we're going to do is we would go to Desmos. We'd go to graphing calculator. Actually, not graphing, my bad. We're not graphing anything here. I'd probably choose scientific, although I guess you could still work it out through the graphing. And then I would say, okay, I want to know what log base 9 of 5 is. You go to function, and then let's see, do they have how to change the log on here? They do not. I thought we had a change of log. Let me just see really quick. I'm going to do a quick Google search, and log calculator. Let's see. I just want to see if I can find something that lets me change the log base. Log base 9 of 5. So actually, I think what you can do for this one is Oh, I really want to change the baseline. Log calculator, change base. Oh, let's try this. Base 9. Because that's what I'm counting in right now. So let's see if the second one lets me work. Log, whatever. I have no idea what that is. All right, so I'm going to show you guys how to check it with the calculator to give me decimal answers, because why not? It's our last lesson. You can actually use the change of base formula down on the bottom. So let me go back to my screen here so you can see what I'm talking about. So I had log base 9 of 5, right? In that example for number 1. So to change the base, I would take the natural log of 5 divided by the natural log of 9. So log of 5 divided by log of 9. That's how you change the base, and that's how you can use the scientific calculator. Sorry for that brain fart there. So I'm going to go ahead and go back to decimals, because that actually was a good way to do it. First, that would have worked too. Decimals. Bear with me, students. I appreciate you. We're already at the 20-minute mark, or 21 minutes actually. All right, so function log base 5, or log of 5, excuse me, log of 5 divided by function log of 9. And your answer is 0.7324. So for your answer on Google Form, you're going to give me 0.7324. You can say 0.7324. That's fine. All right, don't round it. Just cut it off at that 4th decimal point. So make sure you apply those for that change of base formula that I just showed you. And I'll go back to my screen here. Make sure you use this formula if anything is in a different base. Like log of anything, if it doesn't say just plain log, and let me look at these examples. Oops, that was our notes on. Where's our homework? So base 9, base 3, base 4, base 2. So all these 4, after you condense them, you're going to have to do the change of base formula to give me the decimal answer. The next 4, all you have to do is identify the correct expanded form on your Google, out of your selection on the Google form. Other than that, I'll be online Tuesday and Thursday, but I'm pretty much available for your questions any other time. Make sure you are getting your work done, completed, and submitted by 8:30 on Friday mornings. All right, so if there's no questions, hope to get your answers in this week. If not, I'll hear from you guys this week. Stay safe, guys, and take care of each other. All right, bye.